Welcome, my dear students, Rajak Language School, Grade 2, Secondary Stage. In this video, Chapter 3, Bonds and Forms of Molecules. Chemical Combination. Chemical combination, we previously studied the subatomic structure in detail. We have mentioned that most stable atoms are noble gases or inert gases such as helium, neon, argon. These atoms of these elements don't undergo any chemical reaction under normal conditions with other elements or with each other. Accordingly, they form monoatomic molecules, referring to the electron structure of these elements. We observe that outermost energy level or valence level or valence shell is complete with electrons. All contain 8 electrons except helium that has 2 electrons. Consequently, we can conclude that for an element to be stable, its outermost energy level should also be completed with electrons as shown in this table. Noble gas electronic structure, as you see in this table, we have helium He2 1s2, neon 10 may be distributed as to the nearest noble gas helium He2 2s2 2p6, argon Ar18 to the nearest noble gas neon 10, so the rest is 3s2 is 3p6. Observe the last level or the outermost energy level is filled completely with electrons. Krypton Kr36 Ar, argon 18 4s2 3d10 4p6, xenon 54 Xe54, krypton to the nearest noble gas krypton 5s2 4d10 5p6, radon 86 to the nearest noble gas xenon Xe54, the rest 6s2 4f14 5d10 6p6. All other elements except noble gases undergo or make under normal conditions, they are reactive to some extent. They undergo chemical reactions to complete their outermost energy level by accepting, losing, or even sharing a number of electrons to acquire identical electron configuration as that of the nearest noble gas. As a result of this, a change in the number of electrons in outermost shells of atoms, bonds are formed or bonds are broken between atoms to form bonds. This is we call a chemical reaction. So chemical reaction is what? As in third prep, chemical reaction is breaking up of the bonds in reactant molecules to form new bonds in the product's molecules. If chemical bond is not formed or broken among the atoms, there is no chemical reaction. For example, an iron filling is mixed with sulfur. If iron filling is mixed with sulfur powder, the product is a mixture, not chemical compound. This is a mixture. But if this mixture is heated to a high enough temperature to form chemical bonds between them, we say in this case a chemical reaction has occurred between iron and sulfur, producing the compound iron sulfide. Valence electrons play, valence electrons means electrons in the outermost energy level play an important role in the nature of the bonds. Scientist Lewis used a simple method by expressing valence electrons with dots or dot diagram as shown in this table. Group 1A, Group 2A, Group 3A, 4A, 5A, 6A, 7A, Group 0 or inert gases or noble gases. Period 3, we will take period 3 as example for Lewis electron dot symbol. Na sodium ends with 1 electron in outermost level, sodium 11 Na11. So electronic configuration or electronic distribution Ne neon 3s1, Mg12 neon S3s2, aluminium Al13 neon 3s2 3p1, silicon 14 neon 3s2 3b2, 15 phosphorus 3s2 3b3, 16 sulfur 3s2 3b4, chlorine 3s2 3b5 to the nearest noble gas neon, argon neon, then 3s2 3b6. Here we will make Lewis dot diagram. 4 Na 1 dot, 4 Mg 2 dots, for 3A 3 electrons by 3 dots from left to right clockwise. 4 silicon that has 4 electrons, 4 dots. 5 electron phosphorus, 4 dot clockwise from left to right, then pairing 1 electron. 4 sulfur that has 6 electrons, we will distribute the 4 single electrons first, then pairing 2 pairs of electrons. Chlorine the same, we will distribute electron first single, then pairing after that, and the 7th electron is single. 18 argon 18 has 8 electrons in pairing form. Lewis named electron pair found in one of outer orbitals that don't share in the bond formation by expression lone pair of electron. So the lone pair of electron, it is a pair of electrons that doesn't share in the formation of the chemical bond. And Lewis also showed that electron pair responsible for the bond formation by expression what? Bond pair. So the bond pair of electron, it is the pair of electrons that responsible for formation of the chemical bond. We will study two kinds of the bonds, which are firstly chemical bonds, secondly physical bonds. Firstly, chemical bonds. Chemical bonds have 3 types of bonds that are, or those are, ionic bond, covalent bond, coordinate bond. Ionic bond is usually formed between metals and non-metals. Metals, from the first term, they locate at the left-hand side of the modern periodic table. Non-metals locate at the right-hand side of the modern periodic table. It is known that atoms of metals are characterized by their large volumes. Accordingly, their ionization energies are very low. This facilitates or eases the loss of their few electrons of the outermost shell. Metal atoms are then changed to cations. Cations means positive ion that have identical electron structure to the nearest noble gas in the periodic table. On the other hand, non-metal atoms are characterized by their small volumes. Accordingly, their electron affinities are high, and this facilitates the gaining of electrons, those lost by metal atoms. Non-metal atoms are changed into anions, means negative ions, with identical electron structure to the nearest noble gas in the modern periodic table. Consequently, an electrostatic attraction occurs between the positive cations and negative anions. This is called ionic bond. This means that ionic bond has no materialistic existence, and it is usually formed between elements of the two extremes of the modern periodic table. The left-hand side containing metals and the right-hand side that containing non-metals. Does the difference in electronegativity between bonded atoms play a role in characteristic of ionic bond? To answer this question, examine table 3.2 that compares the bonding of chlorine that belong to group 7 or from halogens to sodium, magnesium, aluminium metals that belong to the first, second, third group respectively. All four elements belong to the third period, where electronegativity of chlorine equals 3. Here sodium group 1, magnesium group 2, aluminium group 3, while chlorine group 7 or halogen, sodium electronegativity equals 0.9. So chloride compound NaCl, Mg electronegativity equals 1.2 MgCl2, the chloride compound. Aluminium electronegativity equals 1.5, it's a chloride with chlorine AlCl3. Difference in electronegativity 3 chlorine minus sodium 0.9 equals 2.1. 3 minus 1.2 for magnesium equal 1.2 in magnesium chloride. 3 minus 1.5 equals 1.5 in AlCl3. Melting point, boiling point, electrical conductivity for molten chloride. We will identify, or we will conclude that melting point and the boiling point and the electrical conductivity will be higher in NaCl than MgCl2, while AlCl3 doesn't conduct electric current, means it is a covalent compound, not ionic compound. It is clear from the table the difference in electronegativity increases. When the difference in electronegativity increases between the two bonded elements horizontally, the ionic character increases. It is proved experimentally that when the difference in electronegativity is more than 1.7, then the formed compound is ionic. For example, a compound like sodium chloride is definitely ionic in character as reflected in its physical properties such as boiling point, melting point, and got electrical conductivity when compared to a compound like aluminium chloride, in which a covalent bond character is more apparent than ionic from examination of its physical properties such as boiling point, melting point are low. Also, it doesn't conduct electric current, means the difference in electronegativity between chlorine and the aluminium in AlCl3 is 1.5 less than 1.7. This video ended here at ionic bond. We will continue and complete the covalent bond inshallah in another video. See you later.